Hi, in this video we will discuss how multipath can be a source of excessive layer 2 retransmissions, right? Okay, so for that to really understand we need to know what multipath is initially and how does it really work. So let me spend 2 minutes on multipath. Let's say there's a source that wants to send traffic, there's a destination that wants to receive traffic, right? This source is having an omni antenna on it. An omni antenna will basically scatter the information in the air in a form of a bulb, right? So that same data will be sent out in multiple directions, and it is expected to reach the destination in multiple ways. So let's say the primary signal reaches the destination like this with the information that it needs to send. There's another signal that kind of gets reflected from the wall and reaches the destination in another way, and there's another signal that goes in this direction, gets reflected from the floor and reaches the destination in this way. Okay, now multipath can actually cause something called inter-symbol interference. Okay, now the difference in the time taken by multiple signals to reach the destination is called delay spread. Okay, let me write this down. So the difference in the time taken between these three signals to reach the destination with the same data is called delay spread. Now because of that, what will happen is the receiver can have problems demodulating the RF signals information, right? Because it's reaching in different directions and basically can cause a lot of demodulating problem for the receiver, that is for the destination, and thus can cause data corruption, right? Now if data corruption happens, we know that the destination will not send an acknowledgement back because it's not able to decode properly, which will result in high L2 retries. Okay, now this is a very common problem in networks running 802.11a, b and g. Multipath has been a major problem in networks running a, b, g. Okay, and that is why this problem is kind of solved in 802.11, and in fact one of the major reasons why .11n came in the picture was to solve the problem of multipath, because this uses something called MIMO. I'll discuss about this later, but anyway, yeah, so coming back to multipath, the different signals reaching the destination as a result can cause ISI, that is called inter-symbol interference, and thus causing data corruption, which is going to increase the layer 2 retries because there is no ACK coming from the destination anyway, right? Now how do we solve this? Usually in networks which are already deployed networks, deployed Wi-Fi networks, what happens is it's expected to do an active survey after deployment. So basically when a network is deployed, you give it some time, you basically let the network cook and let the users come and connect and basically give it 2 weeks, 3 weeks, 4 weeks, or sometimes 2-3 months, and then you go on the site and do an active survey. A part of active survey is also something called a spectrum analysis. Okay, now in a spectrum analysis you figure out the source of interference. Okay, and source of interference, and trying to figure out what could be the likely cause for high layer 2 retries. Now in a spectrum analysis, if you do not see any other source of interference, or you do not see any other likely cause for L2 retries being very high, you basically say it's because of multipath. Okay, and it is very common in networks that are running .11 ABG, right? So what you do is, this is how you figure out if there's a multipath problem happening in the network or not. So you do two things to prevent that. Okay, one is you use standard indoor diversity patch antennas, okay, which can be used to make sure the reflection doesn't happen, and that's basically a cure of networks in which we are seeing high multipath, especially in the indoor environment. Okay, just so indoor lobbies or any where there's too much glass involved, glass ceilings or glass doors or glass rooms, or in those kind of areas where you can expect the reflection to be extremely high, that's where you use number one, indoor diversity patch antennas, or you can also use the .11n protocol, which is kind of using MIMO and thus preventing multipath. So what it does is, in MIMO there is a technology. I'm not going to go in detail because this is covered in the fundamentals course anyway in detail. There's a whole chapter of .11n that I've made with 6 or 7 videos, which I've discussed entirely of what MIMO is and the other features of .11n. But I'll tell you what this does in a nutshell. With the MIMO technology, the source and the destination, when there are multiple beams arriving at the destination has the power to adjust the arrival time of the beams so that they all come together to the destination and are all constructive in nature. Okay, and thus making sure there is never inter-symbol interference, there is never any delay spread, and thus making sure the beams are combined when they're coming together and the amplitude is further risen, which means the signal brightens up even more. Okay, so .11n is the technology to go for if you're seeing high multipath, and I think by now every network in the industry is anyway using .11n or higher technology, or .11ac and .11ax. So I think this is pretty much taken care of now. But there are like very old networks that I have worked on. I mean, recently we actually changed the entire network. That network was 9 years back deployed, where they were using .11 AVG protocol, and multipath was a huge source of problem there. Okay, so that's pretty much what you do. You make sure that you deploy these things. It's very common in very old deployed warehouses, where the networks were once deployed and was never touched. They have metal shelves which can cause high amount of multipath also. So yeah, of course, use of high indoor diversity patch antennas, and or just simply move to .11n protocol, which is gonna fix your issues anyway, right? So this was multipath. And again, if you want to know in detail about what multipath is or what .11n is, there is a whole course that you can go to. That is the Wi-Fi fundamental course. Go ahead and watch that, and you'll learn all about this. Thank you very much. See you in the next video.